Okay, hi class. I'm going to do one last vector on the math treatment here of the different components. What we're going to do is we're going to add components. And so I kept all the same equations here because these all work for any any vector pretty much. We're going to add them, add two vectors together, and then we can still use all the same equations for the resulting vector. Okay, so I still have my vector A here. What I'm going to do is I'm going to add a vector B to that. Okay, so that's going to be vector B. And then label that. So that's going to be vector B. Okay, and vector B will have components Bx and By as well, just like Ax and Ay with its components. Okay, so what we want to do is we want to add these two vectors. And the resulting vector is going to be, we're going to call R, and that's usually our standard notation or name for this type of vector, or vector for position. So that's going to be vector R. Okay, so if we want to find, of course, vector R is also going to have a X component and a Y component. And if we want to figure that out, all we need to do is we just take all this, move it back down, and then we can also move, so that was Bx, we can move a Y over here. And we can see that we just add the two. It's really as simple as that. And so then this would be Rx. This would be Ry. If we can just see that we add them together there. So we can see that Rx, X, and I'll add that on like usual, is going to be, I can't do these in colors. We'll just do it like that. So, and we can just add them like vectors, like we did before. Okay, so these are vectors. And then we add the other ones, those are also vectors. So this is going to be Rx equals Ax plus Bx. I'll add those on. 3x's. One X. And so these are actually still vectors too. They can be components or vectors. But since they have a direction here, we're going to treat them as vectors. Okay, and then Ry. Ry. Okay, we're going to do the same thing here. Okay, that's really all we need to know. We'll put this over with these. And so if we want to find r, if we want to find the length of r, then we would plug it into this equation. So r squared is going to equal r sub x squared minus r sub y squared. And I'll go ahead and label these on here. So that's going to be that's r sub x, that's r sub y. Okay, yeah, you would just plug them into these equations, and that's in the book. If you want to find this angle here, theta, then we would use ry over rx again, so that's going to be opposite over adjacent. And that's pretty much the mathematical treatment of vectors. There's more math and examples and types of things in your book, but this should help you get started. I know this is a lot of math, but this is really all you need to know as mathematical as we're going to get with the vectors. If you need some help with trig, okay, so here's one example. Let's say that this is going to be, x is going to be 4 meters long, and this is going to be 3 meters long. I'm going to switch to my calculator real quick, and I'll show you how to do that for trigonometry. Okay, so here's my calculator, and I'm in scientific mode, and the way you go do that this is for Windows 10, is scientific. And let's say I want to do the tangent. So this is standard, and I want to do an inverse tangent. So I don't see the inverse tangent, -1, so I have to go to this button here, actually. And so we'll say it was opposite over adjacent, and opposite was, or, well, let's go back and see what it was. Okay, so we want to find that. So it's opposite over adjacent, so that's 3 over 4. Okay, go back to calculator. Okay, so 3 divided by 4 equals that, inverse tangent, and so that's our angle, and that's in degrees, actually. And then, so you got to make sure that's on degrees. If that's in radians, it would be something different. But we'll just plan on using degrees. I'm going to show you what that would be in radians. 3 divided by 4. So that's what it is in radians. But we're going to use degrees. And so then all the normal stuff from here. So say if we wanted to figure out the angle of, another way to figure this out is we can do, okay, anyway, that's good for vectors. What I was thinking is we could figure out any of these other quantities. not knowing each of them. And it kind of depends. So we just figured out the angle. And a lot of times you'll need to figure out the angle. Sometimes you'll know the angle and need to figure out the hypotenuse. And sometimes you'll know the angle and the hypotenuse. And obviously that way you can figure out each one of these components. But through any of these equations, you should be able to figure out anything you know about the situation. And please go ahead and ask me if you have any questions. And that's going to wrap up our lecture for vectors for now. Thank you.